Hello students, let us solve a problem from NEET UG Paper 2020. Here is the problem. In this problem, you are asked to find out the average thermal energy of a monatomic gas. So here there are four options: half kVt, 3 by 2 kVt, 5 by 2 kVt, 7 by 2 kVt. You have to find out the correct option out of these four. And here kV is Boltzmann's constant and T is the absolute temperature. So this is a very simple problem. It is given from kinetic theory of gas. This problem can be solved easily if you remember the law of equipartition of energy, and let us recap that first. So according to law of equipartition of energy, in thermal equilibrium, the thermal energy is equally distributed amongst its various degrees of freedom, and energy associated with each degree of freedom will be half kVt. So if you can find out the total number of degrees of freedom for this monatomic gas, then multiply that number with half kVt, then you will get the average thermal energy for this gas. So the main aim here would be to find out the degrees of freedom for monatomic gas. And see, degrees of freedom can be written as F is equal to 3n minus L. So where n is the number of atoms, okay, number of atoms in the sense in this case it is 1 because the gas is monatomic gas. Okay, now what is L? L is the number of constant in the motion or in the dynamics of the gas atom. So if there is only one atom in the gas, if this is a monatomic gas, that means it has a single atom in a molecule, so it has only translational degrees of freedom. There is no vibrational degrees of freedom and no rotational degrees of freedom, and there is no constant equation which limits its motion, translational motion. So therefore L is equal to 0, and hence we see the degrees of freedom for a monatomic gas will be 3 into 1 minus 0, that is 3. And since each degrees of freedom will share half kVt of the energy, total thermal energy, then the average thermal energy for a monatomic gas will be 3 by 2 kVt. 3 is the degrees of freedom and half kVt is the energy shared by each degrees of freedom. So this is the average thermal energy for a monatomic gas, and hence the second option will be the correct answer for this question. Thank you.